Hi everyone, welcome back to Lulumath. This video is on evaluating fractional bases with integer exponents. And I actually want to specify that these exponents are actually whole numbers, so they're only positive integers that we're looking at for these videos. So for the background knowledge or background information you need, we need to know how to multiply integers and fractions, and we also need to know how to evaluate negatives with exponents. So let's go ahead and take a look at our first example. We want to evaluate x squared when x equals 1/4. So just like we did before, we take the 1/4, we replace the x with 1/4. So I'm going to say 1/4 is being squared. But here's the thing. Everything is being squared. So not just the 1, not just the 4, the entire 1 divided by 4. So that means that we have to have brackets around our base if our base is a fraction, just like we had to have brackets around our base if our base was a negative number. Okay, so now let's evaluate this. So 1/4 squared means 1/4 times 1/4. And then when we multiply, we just multiply across. So 1 times 1 is 1. And then 1 times 4 is 16. So my answer is 1/16. A quick note, without the brackets, you were just saying that we're going to square the 1 and then the 4 stays as is, so we don't get the correct answer. Okay, now we want to evaluate x squared when x equals -2/3. So we're going to take -2/3 and we are going to square it. Now, because this is a negative and a fraction, even more reason that we need to make sure to have our brackets here. So what this means is I'm going to take 2/3 and multiply it by 2/3. However, they're both negative. So I will put the negative in front right here. So my negative is written in front of the fraction. So essentially, when I'm looking at this, I can see I have a negative multiplied by a negative, and that will turn into a positive. And then 2 times 2 gives me 4. 3 times 3 will give me 9, so I get +4/9. So 4/9 is my final answer. Now, a couple quick things. I could have chosen to make the 2 negative, so I could do -2/3 times -2/3. And then when I multiply a negative by a -2, I get a +4, and then 3 times 3 is just simply 9. I could have also decided to make the 3 negative, so 2/3 times 2/3. So 2 times 2 is +4. -3 times -3 is +9. What I cannot do, though, is do -2/3 because the double negatives cancel each other out and become a positive. I could even do -2/3 times +2/3 as long as only one of my numbers in my fraction is negative. So then this would become -2 times 2, which is -4, and then 3 times -3, which is -9, and the double negatives cancel each other out to become a positive. Any way you look at it from these options is fine, but you cannot do double negatives because, again, the double negative turns the original fraction into a positive. All right, let's move on. So now we want to evaluate x to the power of 3 if x equals 1/4 again. So this time I will take 1/4 and I will raise it to the power of 3, don't forget your brackets, so I will get 1/4 times 1/4 times 1/4. Well, 1 times 1 is 1, times another 1 is also 1, and then 4 times 4 is 16, times another 4 is 64. So I get 1/64 as my answer here. Now, if I take x equals -2/3, that means I would take -2/3, and then I would cube it. So again, you can choose which number you would like to be negative. In this example, I will make my numerator negative. So -2/3 times -2/3 times -2/3. When I multiply across, -2 times -2 times -2 is a -8, and then 3 times 3 times 3 is a +27. So my answer is -8/27. Now, if you caught the video on evaluating negative bases with integer exponents, we figured out that if we have a negative value raised to an odd power, we will get a negative answer, which is exactly what we got here. Now, I want to make another note. for this example here, I could also say that I'm just cubing everything inside of my bracket. So I will cube my numerator and I will cube my denominator. So 1 cubed means 1 times 1 times 1, which is 1. And then 4 cubed means 4 times 4 times 4, which is 64. Same thing is true in this example over here. So negative 2 over 3 cubed means negative 2 cubed over 3 cubed. And just like we said here, negative 2 times negative 2 times negative 2 is negative 8. And then 3 times 3 times 3 is 27. Now I want to evaluate x to the power of 4 when x equals 1/4. So I will take 1/4 and raise it to the power of 4. So I could do 1 to the power of 4 over 4 to the power of 4, and 1 to the power of 4 is 1, and 4 to the power of 4 is 256. Or I could take my answer of 1/4 to the power of 3 and multiply that by 1/4 again, because when I multiply, I add my exponents, and that would give me 1/4 to the power of 4. And we already figured out that 1/4 to the power of 3 is this 1 over 64 here. And then multiply that by an additional 1 over 4. And 1 times 1 is 1. 64 times 4 is 256. And that's how we get the same answer. Now let's go ahead and look at x equals negative 2/3. So I will take negative 2 over 3 and raise this to the power of 4. So this time I'm going to keep the numerator positive and the denominator, I will make it negative and raise that to the power of 4. So that means that I will have 2 to the power of 4 over negative 3 to the power of 4. And 2 to the power of 4 means 2 times 2 times 2 times 2, which would give me 16. And then negative 3 to the power of 4, just a reminder that a negative raised to an even exponent is positive, because if it's raised to the power of 4, that means we have 4 negatives, which can be split up into 2 groups of 2 negatives, and each group of 2 negatives multiplied together will become a positive, right? A negative times a negative times a negative times a negative. These two become a positive, these two become a positive, and a positive times a positive is a positive. Now to evaluate this, I just need to know 3 times 3 is 9, times another 3 is 27, times another 3 is 81. So this right here will be 16 over 81. Or like we did up here in this example, we could also take negative 2/3 raised to the power of 3 and multiply that by negative 2/3 raised to the power of 1. And here we got negative 2/3 raised to the power of 3 was equal to negative 8 over 27. And then I can multiply that by another negative 2/3. And when I multiply across, negative 8 times negative 2 is positive 16. And then 27 times 3 is positive 81. So that's how I get 16 over 81. All right, one last example. Evaluate x to the power of 5 when x equals 1/4. So here I will take 1/4 and multiply it by itself 5 times. Or I could take 1 to the power of 5 and 4 to the power of 5. Or I could take my answer from 1 over 4 to the power of 4 and multiply that by another 1/4. Any of the options that I'm giving you here are all totally mathematically acceptable. So when I multiply across, all of these ones multiplied together give me 1. And when I multiply across here, all these 4's multiplied together give me 1024. So my answer is 1 over 1024. Now here, when x equals negative 2/3, I will take negative 2/3, raise it to the power of 5, and we had determined in the previous video that a negative base raised to an odd exponent will be negative. And since this is to the power of 5, this is saying that we have 5 negatives being multiplied together. So these two will become a positive, these two will become a positive, and then a positive times the remaining negative will give us a negative. So we can go straight to saying that our final answer here will be a negative. So here when I multiply it by itself 5 times, we know our final answer will have a negative in it. And then when I just multiply across, all of these 2's being multiplied together 5 times will give me 32. and all of these 3's being multiplied together by itself 5 times will give me 243. And this is my final answer. So in conclusion, you must always, always, always put brackets or parentheses around any fractional basis, regardless of the sign. Whether it's positive or negative, you always have to do that. And just like we discussed in our last video, this conclusion has not changed. A negative base, regardless of whether it is an integer or a fraction, raised to an odd exponent will be negative, and raised to an even exponent will be positive, because the rules for multiplying negatives don't change depending on whether we have an integer or a fraction. They're still exactly the same. And that's it for this video. If you have any questions, please let us know in the comments below or at lulumath.com, where you can also find blank or completed notes for this video. If you found this to be useful, please share with others and subscribe. Thank you, and we'll catch you next time. Goodbye.